for a beam of rectangular cross section having width b and h is the height. So if you take a rectangular cross section, the total height is given as h and it is having a width b. If the cross sectional area is doubly symmetric, so along the length, along the width, it is doubly symmetric, so it is h by 2 and it is h by 2. So what we have to find out, sigma v is the yield stress that is given. What is the value of plastic moment of this same rectangular beam? For this rectangular beam we have to find out the plastic moment. So we know plastic moment MP is equal to sigma y into z, where z is the plastic modulus. Plastic modulus. So plastic modulus z is equal to a into y1 bar plus y2 bar divided by 2. That is equal to area of the rectangular beam BH. This 2 comes here. From the center, the centroid distance is h by 2 by 2. That is h by 4 plus h by 4. That is equal to BH square by 4. Right? By substituting this value in the equation 1, MP is equal to sigma y, z is BH square by 4. So option C is correct. Beyond that, we can find out the shape factor. Actually, shape factor is equal to MP by My. MP we know BH square by 4. My, what is My? Sigma y into actually section modulus, that is equal to BH square by 4 divided by sigma y BH square by 6. Sigma y is also going to be here, sigma y. Therefore BH square is cancelled, 6 by 4, that is equal to 3 by 2. Actually the shape factor of a rectangular beam having a width of b and h, and the condition is cross section is doubly symmetric, the shape factor is going to be 3 by 2. This also is going to be one of question. So for this question, plastic moment they have asked, so the plastic moment is sigma y into BH square by 4. So option C is correct. Question is, a beam of square cross section with side of 100 mm. So square cross section with side of 100 mm is placed with one diagonal vertical. These are diagonals and we have placed one diagonal vertical. What is the maximum shear stress if the shear force acting on the section is 10 kilonewtons? So the average shear stress when placing the one diagonal vertical is 9 by 8 F by B square, that is equal to 9 by 8 F is 10 into 10 cube, B is 100 mm square, that is equal to 1.125 Newton per millimeter square. So option B is correct. Question is, a simply supported beam of ABC of length L carries a concentrated load P at an intermediate point B. We don't know at which location it is acting. If you see the figure A, C, if it is acting at B, we don't know the distance, but entire distance is of L. So let me take it as A and B. The condition is given as, if the slope at A is 0.75 times the slope at C, slope theta A is equal to 0.75 times the theta at C. If you see the simple slope diagram A and B, so the maximum deflection that is going to be there because of this load P E A B by L E I. If you draw the triangle from the symmetrical triangles, we can say it as tan theta, theta 1, theta 2, theta A, theta B. So we can get that A is equal to 5 by 7 L. So option C is correct. We have to find out the differential settlement. If the distortion of 1 by 300 is allowed between two columns of 6 meter length, two columns are 6 meter apart, L is 6 meter we can say, and the distortion is given as 1 by 300. Let me take it as theta. So we have to find out the differential settlement, that is S1 by S2. First column settlement is S1, second column settlement is S2. So the differential settlement we can say it as S1 minus S2. So distortion is equal to differential settlement S by L. S is equal to theta into L. That is theta is 1 by 300 into 6. That is equal to 20 millimeters. So option A is correct. Option is a single acting steam hammer weighing 2500 kg is given. So W is given as 2500 kg. And falling from a height of fall is given as 1.2 meters, that is equal to 120 centimeters. Driven in a pile to an average penetration depth is given as 0.85 centimeters under the last few blows. Find allowable load on pile according to engineer's news formula. Engineer's news formula, the load carrying capacity of the pile QA is equal to WH by 6 into S plus 0.25. Here S and H are in centimeters. So that's why we converted this meter into centimeters. So W is 2500 kg as it is an empirical formula. So H is 120 divided by 6 into 0.85 plus 0.25. That is equal to 45454.55 kg. So option A is correct. We have to find out the factor of safety of infinite slope. Extend having a slope angle with the horizontal. Slope angle with the horizontal is given as 29 degrees. Let me say it as I. And the slope consists of a soil having an effective value of C. C is given as 0 and phi is given as 32. So the factor of safety F is equal to tan phi by tan I. That is equal to tan 32 degrees divided by tan I is 29 degrees. That is equal to 1.127. So option D is correct. The question is, at a point on a streamline, the velocity is 3 meters per second. We collect the data from the question, that is 3 meters per second, right? And the radius of curvature is given as 9 meters. Radius of curvature is given as 9 meters. If the ratio of increase in velocity along with the streamline at this point is, so dou V S by dou V is given as 1/3 meters per second. Well, the total acceleration at this point will be, we have to find out the total acceleration A. So we know that for a streamline, total acceleration A is equal to root of as square plus ax square. As square is V into dou V S by dou S whole square plus V square by R whole square under root. V is 3 meters per second, we know. This is 1/3 square plus V square is 9 by radius of curvature is given as 9 whole square under root, that is equal to root of 1 plus 1, that is equal to root 2 meters per second square. So here option D is correct.